Hello everyone, I'm Michael from Datong Forever Energy. Today is our one last class of this course, and I would like to introduce you the grid connection part of the PV system work. We have talked a lot about the construction phase of the system, but at the end of the day, they all need to be transferred to the electricity company. This is what we will be discussing today, the connection part. Today I will be focusing on the examples here in Taiwan. The main business model here is that we give out the energy generated by our modules, and we share part of the electricity bills paid by the public. The energy storage industry is still at its early stage of development, probably not just in Taiwan but in the whole world. So far, our main revenue stream still comes from the share the electricity company gives us. So the grid connection part is very important in this industry. Construction efficiency is vital in terms of grid connection. If we finish the connection earlier, we got our revenue earlier as well. Aside from the construction aspect, there are a lot of documents to be processed before the grid connecting. So today I would focus not only on the construction aspect, but also the documents processing. Here you can see the process listed out. First, we examine the project implementation procedure. We have talked about some of the steps in previous classes, so I'll be passing by them quickly and focus more on introducing the document preparation. Take Taiwan for example. Our public electricity company is the Taiwan Power Company, the TPC. The very first step of our work is to negotiate with the TPC. Before negotiation, we must hand in a grid connection plan first for them to do the reviewing and the evaluation. Aside from the TPC, we also need to contact the Bureau of Energy, which is the main governmental agency in charge of the management of this industry. After we got our verification issued by the Bureau, we also need to contact the local public construction department and Office of Building Administration to apply for approval. All these procedures are to prove that our construction plan is good to go in terms of safety and legibility. After getting the green light from the government, we start the negotiation and discussion with TPC about how we're going to do our construction. Then we do the construction and sell the power to TPC. The most time-consuming part is actually not the construction itself, but the document application. So we tend to try to do different stages of work simultaneously to save our time as much as possible. Here we list out some important points regarding the grid connection work. For example, we try to avoid the cases which include road digging because it is not our right to apply for it. We need to ask TPC to do this application for us. Secondly, wherever we plan to put our modules on, we need to get the approval from the owners of the buildings, for instance, schools or city government. Thirdly, another factor which can affect our location choosing is the future maintenance cost. We also need to pay attention if there's any possibility of water leakage. Another example of our negotiation with TPC. If the capacity of the transformer on a pole is 50 kilovolt ampere, the original connection limit is 86.6 kilowatt peak. Yet through negotiating, we can maximize our output up to 99 kilowatt peak. Now, down here, you can see some basic rules we have in Taiwan. If the system's capacity is lower than 20 kilowatts, it can be connected to a 3-wire single-phase transformer. If the capacity is lower than 100 kilowatts, it can be connected to 2 3-wire 3-phase transformers. If the capacity is lower than 500 kilowatts, we can connect to three 4-wire, three-phase transformers, or other equipment which can handle higher voltage. Then what's the difference between those wires and phases of the transformers? The three-phase transformers have more completed wiring and better ability in process the high voltage power than the single-phase ones. So the single-phase transformers are more for family use or such. In the past days, when the power consumption was not so highly demanded, we usually connect our network directly to the existing user connection points. So far, we only have word descriptions of them. Later I'll show you some pictures for you to understand better. What are the user's connection points? If you open it up, you'll see the wires coming from the user connecting to TPC's cables directly with tapes. If we want to connect to the transformer on poles, since the cables can't be connected directly to TPC's transformers, we need to put on a new distribution box with guarded switch inside next to the transformer for the connection and also to be used as demarcation point. If we do the connection directly to the transformer, our cable can either go overhead or beneath. Yet, as we have mentioned, we try not to go beneath since it requires too much work and time to dig up the roads. But of course, our choice would be based on the actual situation on site. Here are some regulations or suggestions for our system designing. For example, the cable tray must be at least 15 centimeters above the ground to avoid energy lost caused by ground temperature. These are some basic rules to follow while designing. These are the documents we need to hand in to the TPC for their review. For example, the wiring plan, the plot plan, which includes the design of modules, inverters, and AC or DC boxes. The most important part of this document is the marking of demarcation points. Of course, regarding the demarcation points, it's not fully our right to make the decision. We need to talk to TPC's engineers on site to determine the ubication. The riser diagram and then the electrical meter plan must be included as well. Later, I will show you the real examples of those documents, since the simple word description is a bit too vague. When it comes to the pre-construction examination, we need to check with TPC if there's existing electrical meter already, in order to be fully prepared in case there is no meter installed, which might sabotage the whole project. If our project requires higher voltage equipment, we need to get the approval of the owner of the site first, for instance, a school or any local user. In this case, usually we need to find an additional location for new distribution equipment. We do this part of work collaborating with the TPC. We will collect all the documents required and send a hard copy to the TPC. Once it arrives at the TPC, there will be two departments reviewing our application, the inspection section and the planning section. Let's say it in an easier way. They separate the reviewing work into two aspects, the inspection on paper and on site. The main work of the on-site inspection is to determine where will the demarcation point be. On the other hand, the document inspection focuses on if our design meets the regulation and standards. If they all pass, then the TPC will officially approve our application. Here is the information regarding the grid connection voltage. As we have previously mentioned, we use the single-phase 3-wire transformer for the current lower than 220 volts. If the equipment can handle higher voltage, we use 3-phase, 3-wire or 4-wire transformers to handle the current higher than 220 volts. The 3 wires are the R, S, and T wire, and the additional wire of the 4-wire one is the N wire. Either the 3-wire one or the 4, there will always be an E wire connecting to the ground. So, generally speaking, there are actually 4 wires in the 3-wire one and 5 wires in the 4-wire one, for your information. When it comes to even higher voltage, here in Taiwan we commonly have the 11.4 or the 22.8 kilovolts equipment. Usually the transformers on the poles are the 11.4 kilovolts ones, and the 22.8 kilovolt systems are usually hidden beneath the ground. If in other countries, they might be only 11 or up to 33 kilovolts, depending on the setting. And about the grid connection types, both low and high voltage cables can be divided into two, going on poles or underground. Let's talk about a single-phase 3-wire system between 110 and 220 volts first. Here in the photo, you can see that there is a single transformer on top of the pole, usually for lower household electricity usage. And you can see that the area of the rooftop of the residential houses is pretty limited as well. So at most, we can put the module lower than 20 kilowatts on it. Here I marked the demarcation points with red circles. Here we do that on the connection point on the wall, which is the entry point into the house for a lower voltage cable coming from the transformer. Some of the entry points are set directly on the wall of residential house. Sometimes they put another smaller pole right next to the house for the lower voltage entry cable. Either way, there will be an electrical meter by the entry point. Therefore, once we arrive at the new site, the best way to find out how many transformers they are connected to is to count the meters. This is the case of residential areas. Following up, I'm going to talk about the case of 3-phase, 3-wire transformer which holds current of 220 volts. Usually, this kind of bigger transformers are for sites like schools or industrial areas. In this case, the cable came from the high voltage public pole, lower the voltage down, then transferred to another pole and the new meter we set up. The demarcation point is marked on the new pole for lower voltage. The side of higher voltage pole is the responsibility of TPC. On the other hand, from the new pole to the meter is our zone of responsibility. This is the function and purpose of the demarcation point. The previous case is on the pole. Now we look at the case of the demarcation point set underground. You can see that there is an existing old meter on the right hand side, and there is a cable down the box connecting into the ground, which leads all the way to the transformer's side. In such site, sometimes we create a new connection point on top of the existing meter, which connects to our new meter set by the side. In this case, the demarcation point is at the connection point between the old and the new meter. Now we're looking at the site which has the cables buried underground. The cables go underground from these 2 water blue transformers directly to the boxes installed on the wall of the buildings in the background. Regarding this kind of wiring plan, we can directly connect our cables to the original ones. So we must install a new box next to the original ones to connect with them, and that will also be where the demarcation point is. On the demarcation point, there will be rigid copper bars for connection, and the amount of those copper bars depends on the type of the transformer and on our demand of electricity. As I have drawn on the picture, there are R, S, T, N, these 4 copper bars inside our box. TPC also has to connect with 4 of their bars, and these bars mark the demarcation point. The 3-phase 4-wire system is actually quite similar to the 3-phase 3-wire one. The only difference is that it bears higher voltage up to 380 volts, for it has one additional wire, the N bar. In a 3-phase 4-wire system, there will always be 3 transformers. The difference between 3 transformers and 2 transformers is also simple. That the connection method divides into delta and Y. The delta connection method applies for the system of 2 transformers. Then the Y one applies to a set of 3 transformers since there is an additional N bar. Regarding the demarcation point, it's at the same place in this case, the copper bars inside our newly installed box. We also installed a new meter here for the purpose to calculate how much money TPC has to share with us. Some systems are like this, installed on ground surface. Then some are like this, all the boxes and equipment are installed in a basement. Usually you can find the TPC's distribution space in a basement. Their transformers will be inside the space. The rest is basically the same. We install a new meter and boxes with copper bars to do the connection and to mark demarcation point. There are many ways of connecting our networks. What we value is the efficiency. Which one is the fastest one to be done? If there are no existing copper bars or boxes owned by TPC for us to do the connection, we need to negotiate with them and find a new spot to do the work. From the bottom right picture, you can see that under several boxes there are black and yellow sashes painted on the bases. That means those are TPC's property. In comparison, the bases of our equipment won't be painted. Once we reached an agreement about where to place our equipment, we bury our own cables, construct the bases, make cable connections from the existing manhole. The cables go into the transformers shown in the bottom left photo. We try our best to avoid the need to dig the road since the approval is not within our ability to apply. Now we see the cable set on poles. It is the same that we need to negotiate with TPC to get a piece of land to stand our own poles. Unlike the underground constructions, which takes a long time to do since we need to apply for approval to dig up the road, it is the same that we need approval to stand the poles, but it takes less time to do so since we don't need to massively cut the road open. We just need the pole to stand firmly. After the installation of the poles, the electrical engineering team will come to put on the transformers. On the other hand, the user needs to stand their own user pole to connect the cable with TPC. Now let's proceed to higher voltage construction part. When we're doing the higher voltage side, the type of meter would be different. The box cover of the meter would be bigger since protection equipment occupies more space. They are approximately 2 meters tall. On the other hand, if we're doing the high voltage case on the poles, there are several expulsion fuses on the pole, and that's where the demarcation point is. This is the blueprint we provided to TPC for your information. This is the arrangement plan of a water surface construction site. It must show data such as the location of each part, the capacity of the modules, capacity of inverters, and floating structure, etc. Aside from the general arrangement plan, we also provide a simpler elementary diagram. As it is shown, the module of this site is connected to a phase 3 wire transformers which carry 22 kilovolts of electricity. We also have negotiated with TPC about the location of the demarcation point, and it is marked on the top right side of the map. That box-shaped mark is the demarcation point. That is where TPC introduces their cables. Now, this is the diagram of the electrical wiring plan, which includes the high voltage meter, the protection switch, and other related equipment. All this information must be reviewed and approved by TPC. This is the plan of our power distribution panel. It also includes a similar information like the protection switches, the specifications of our inverters and modules. This is the AC part. And this is the DC part of chart. It shows the fuse, inverters, and other related information. All this need to be approved. As you can see in the pictures, we circle the construction area up. After securing the area, we start the digging and putting our cables and bury them up after it's done. Then we construct the bases. The meter-like equipment is for the examination of our earth wire. We make sure of that as well. Now all these are the information you need to know before you apply for approval. Thank you for your attention.